There are two main types of electrical circuit: series and parallel. In a series circuit, the components are connected end to end, one after the other. They make a simple loop for the current to flow round. In a parallel circuit, the components are connected side by side, so the current divides, some going one way and the rest the other way. Here's an example of two circuits, both containing a cell and two bulbs. One circuit is series, the other is parallel. The voltage is a measure of the electrical push that the battery gives to the electrons. It's a measure of the energy in joules given to each packet of electrons, coulombs. So the voltmeter measures joules per coulomb, or volts. Voltmeters are always connected in parallel when added to a circuit. In this diagram, the voltmeter is measuring the voltage across the lamp. We can also measure the current flowing through a circuit. In a wire, the current is the flow of negatively charged electrons. We can imagine it being like water flowing in a pipe, but instead of water, it's a flow of electric charge, which we measure in coulombs. So electric current is coulombs per second, or amps, measured using an ammeter, which must be connected in series. Resistance is a measure of the opposition to current flow in an electrical circuit. Resistance is measured in ohms, symbolized by the Greek letter omega. The higher the resistance, the more difficult it is for a current to flow. A good way to think about electricity is voltage as the force pushing the current around, and resistance is as if the pipe carrying the current narrows. For components connected in series, the total voltage or potential difference of the power supply is shared between the components. There is the same current through each component. The total resistance of two components is the sum of the resistance of each component. For components connected in parallel, the voltage or potential difference across each component is the same. The total current through the whole circuit is the sum of the currents through the separate components, and the total resistance of two resistors is less than the resistance of the smallest individual resistor. Let's have a go at applying some of those rules. Each cell provides a potential difference of 1.5 volts. What's the potential difference provided by the four cells in the circuit? What will be the reading on the voltmeter? The current through the lamp is 0.20 amps. The current through the resistor is 0.10 amps. What is the reading on the ammeter? Pause the video while you work out the answers. When resistors are in parallel, things work out a bit different. Look at this circuit. If these two resistors were in series, then their combined value would be 3 ohms plus 3 ohms equals 6 ohms. But when in parallel, we use this formula. In this example, we have if 1 over R equals 2 over 3, then R equals 3 over 2 equals 1.5 ohms. The total resistance is lower than each individual resistor. Try this one. One over R equals 1 over 10 plus 1 over 5, which equals 3 over 10. So R is 10 over 3, which equals 3.33 ohms. How did you do? So now you know how series and parallel circuits differ, and how we can calculate the resistance experimentally.